right, today we're going to talk about something that is, quite literally, the foundation of any good database, SQL data types. And look, I know this might not sound like the most exciting topic, but trust me, getting this right is like being a master architect. These are the choices that determine if your project stands strong for years or crumbles under pressure.
And this quote right here, it just nails it. This isn't just about picking something from a drop-down menu. This is your first line of defense. It's how you guarantee your data stays clean and your application runs fast. Getting this right from day one saves you so much pain down the road. So, what does that actually mean? Well, think of it like building a house. You wouldn't build the foundation out of glass, right? And you wouldn't make the windows out of concrete. Every material has a purpose. Data types are exactly the same. They're the specialized materials for building your database. And today, we're going to look at the architect's blueprint. First up, let's dive into the world of numbers. And right out of the gate, we're faced with the most fundamental trade-off in database design. Do you need absolute, unshakable precision? Or do you need raw, blistering speed? Let's see how that plays out. Okay, for your basic whole numbers, things are pretty straightforward. Integer is your workhorse. It's the default choice for pretty much everything. User IDs, item counts, you name it. You only really need to pull out big int if you expect your numbers to get truly massive, like past 2 billion. And small int, honestly, in today's world of cheap storage, you'll almost never need it. Now, this one is super important, numeric. You gotta think of this as your digital Fort Knox. It stores numbers with perfect, exact precision. No weird rounding errors no matter what. It might be a tiny bit slower, but when accuracy is everything, this is the only choice. And this slide really breaks down that core trade-off. Are you building a bank vault or a racetrack? For things like money, grades, or any financial data, you need the vault. That's numeric. But for scientific measurements or estimates where tiny approximations are fine and speed is key, you want the racetrack. That's double precision, also known as a float. Okay, listen up, because if you take only one thing away from this section, let it be this. Never, ever, ever use a float or a double precision type for money. I'm serious, floating point math can create these teeny-tiny rounding errors. And a fraction of a cent might seem like nothing, but over thousands or millions of transactions, it adds up to a massive, costly disaster. Money always goes in a numeric column. End of story. All right, we've tackled numbers. Our next big architectural decision is how to handle text. And the choice here really comes down to this. Are we going to set aside a fixed amount of space for our text, or do we want something more flexible that just grows as needed? So here's the breakdown. Char is for those rare cases where the text is always the exact same length, like a 2-letter country code. Varchar is for when you know there's a hard upper limit, like maybe for an email address. But honestly, in a modern database like PostgreSQL, the best answer for almost everything, names, descriptions, comments, you name it, is just text. It's flexible, it's efficient, and you don't have to worry about arbitrary limits. It's the simple, correct choice most of the time. Okay, let's talk about time. And oh boy, in our global, interconnected world, this is one of the easiest places to mess things up. The key decision isn't just, how do I store a date? It's, does my application need to be smart about different time zones? And this slide highlights the single biggest point of confusion. Timestamp just stores whatever date and time you give it. It has no idea where in the world that time is from. But timestamp TZ, timestamp with time zone, now that's the hero. It takes whatever time you give it, converts it to a single universal standard, UTC, and stores it that way. Then, when you ask for it back, it can show it to any user in their correct local time. For pretty much any modern app you build, timestamp TZ is the one you want. So we've covered the big three: numbers, text, and time. Now let's open up the specialists drawer in our toolkit. These are the tools you won't use every day, but for the right job, they are absolute lifesavers. First up is the Boolean, which just stores a simple true or false. But here's a really cool and practical feature. Database systems like PostgreSQL are super flexible about what you can give it. You can literally feed it the word yes, on, or just the number 1, and it's smart enough to know you mean true. Same for false. This is incredibly handy when you're dealing with messy data from different sources. Next up is enum. This is fantastic. It lets you create your very own data type from a fixed list of things, like statuses or categories. It's a really simple 2-step recipe. First, you create your type and define the only allowed values. Then, you just use it in your table. This makes it impossible for bad data to get in, which is a huge win for data quality. Now, you are definitely going to run into this one if you're looking at older code or tutorials. The keyword serial. It's not really a data type itself, it's more of a shortcut. It was the old school PostgreSQL way of creating an ID column that just automatically counts up 1, 2, 3 for every new row.
But old school doesn't mean best. The modern, and more importantly, the SQL standard way of doing this is with generated always as identity. It does the exact same thing as serial, but it's the official way, which means your code is more professional and portable. So the big takeaway here is, for any new tables you're building, use the identity method. It's the current best practice.
Okay, we have covered a ton of ground. We've gone from basic numbers to complex time zones and even custom types. So now let's pull all of that wisdom together into one single, simple blueprint that you can use on every project from here on out. And here it is. This is the slide. Go ahead, pause here, take a screenshot. This is your go-to guide. It gives you the recommended tool for every job. Integer for your counts, numeric for money, text for descriptions, timestamp TZ for nearly all your timestamps. Stick to this and you'll be building on a rock-solid foundation every single time.
So, at the end of the day, that's what this is all about. These data types, they're not just a bunch of boring rules you have to follow. They're your building materials. They're the high-quality, specialized tools an architect gets to use to create something that's elegant, efficient, and built to last. Your database is a blank canvas. The only question left is, what will you build?